Okay, here we go with 14.5. So we're going to pick up the lesson pack. So grab your lessons, your notes, and it's right after the 14.4, obviously. So we're right here at 14.5. So we're going to talk about what an inscribed angle in an arc is. Okay. Two important components that you must have. You have to have both of them. This is an and, okay? One, the sides of the angle contain endpoints of the arc, okay? And the vertex of the angle is a point of the arc, but not an endpoint, okay? Again, the sides of the angle contain endpoints of the arc, and the vertex of the angle is a point of the arc, but not an endpoint, okay? So if you look at angle B here, okay, or D, doesn't really make a difference. You can see that the sides of each of those angles contain an endpoint of the arc, right? A, point C, and the vertices, the vertex for D and vertex for angle B is a point of the arc, but not an endpoint, right? So what we're talking about is that these angles are inscribed in angle or in arc ADC, right? Or ABC, doesn't really matter how you want to call it. Okay, so which angles are inscribed in arc ADC? Well, we just said it, didn't we? Angle ABC, angle ADC. Okay, so that's if an angle is inscribed, an inscribed angle in an arc. Okay, different situation here now. An angle intercepts an arc. Remember the word intercept, where we used that before? Remember how with the transversal lines can intercept a portion of or a segment on the transversal? Remember that? Similar here, okay? So we have an angle intercepting an arc if, again, we have each of these three things. The endpoints of the arc lie on the angle, okay? All other points of the intercepted arc are in the interior of the angle, and each ray of the angle contains an endpoint of the arc, okay? Got to have all three of these. Let's go through them again. The endpoints of the arc lie on the angle. Pretty obvious that that has to be the case, right? All other points of the arc are in the interior. If somewhere outside, you're not intercepting that arc, right? And then each ray of the angle contains an endpoint of the arc. Okay, so here's three, and I want you to tell me whether you think that that each of these angles separately intercept an arc, okay? And remember these three things. So what do you think about this one? Answer, yes, yes. Does it satisfy all these? Endpoints of the arc lie on the angle? Yep. All of the points of the arc are in the interior. Is each ray of the angle contain an endpoint? Yes. I know you're maybe freaked out because the vertex was not on the circle. This still complies with those requirements. In fact, this angle intercepts how many arcs in that circle? Two, exactly. Yeah, one there and one there, okay? If you said four and you were thinking like this would be, no, remember that it's got to be within the angle. It's not. Okay, what about this one? What about the middle one here? Hopefully you said yes. And the reason it's yes is it still complies, right? Even though this vertex is on the circle here and we have basically like a tangent here, does that still meet these requirements down here? And particularly the third one, I think that's probably the one that would be most confusing. Each ray of the angle contains an endpoint of the arc. Well, it does right there, right? Each ray, the ray includes the vertex of the angle. That includes an endpoint of this arc we're intercepting in here. Okay. What about this one? The answer to this one would be no, right? This ray does not contain an endpoint of the arc. Okay, so this is not, this angle does not intercept this arc. Okay, and then we have the inscribed angle theorem. It says the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so this is going to be really helpful for us. And there's two cases to consider kind of in thinking about this and kind of improving it. Okay, so we have circle here, and you can see we have radii. So wouldn't you agree with me that the measure of this angle here, R, would equal S plus T? What's the reason for that? Exterior angle equal to the sum of the remote interiors, right? Okay. And if S is equal to T, why? If sides, then angles, then what? Wouldn't that mean that S is half of R? And notice that angle A here intercepts what? Arc BC. Okay. And what is arc BC has what degree, what measure? The same as whatever angle R is, right? So if S is basically half of R, which is half of arc BC. Okay. Okay, another scenario is this one. Okay. And in this case, we know that T is equal to half of R, right? Right? T is equal to half of R. And we also know that U would be equal to half of S. Okay. Okay, let's add it together. T plus U would be equal to what? Half of R plus S. Okay. Well, isn't the measure of angle A equal to the measure of T plus the measure of angle of U? Why? Right angle addition. Okay. And isn't it true that the measure of BDC equals R plus S? So think about what we have there. Doesn't that mean that angle A is equal to half of that measure? Okay. All right, corollary. Any angle inscribed in a semicircle is a right angle. Why? Because what's the measure of a semicircle? 180. The inscribed angle, right, is half the measure of its intercepted arc. So half of 180, which is 90. Another corollary, angles inscribed in the same arc are congruent. Exactly. All right.